team. Happy Wednesday. This time we are one day early. Usually we go out and do live sessions on Thursday, but I think the topic was kind of super interesting that got me kind of doing this at least one day earlier. And it is about real time analytics, it is about StarRocks, Celerdata, data engineering, real time analytics. Like I mentioned, real time analytics. I'm so excited about that, but data lake analytics solutions as well. So we'll have Rachel with us, Rachel Beddor, who's a solution architect at Celerdata. We'll be discussing a lot of topics. I can already see Ryan is up here and excited for this one. Ryan, I'm trust me, I'm equally excited about the session and can't wait to learn more about data lake analytics from Rachel. But like we always do on our show, we always do a very cool giveaway, and this time it couldn't get any better because what we are doing is giving away two signed copies of Data Engineering Fundamental book by Reis and Matt. We are also doing an iWatch giveaway. What you need to do is obviously register for the event. I already saw more than I guess 300 folks registering for the event, but not only just that, for quick entering the raffle quickly, you can always type in hashtag Celerdata in the chat, and we'll be collecting all of these names and accordingly picking the winners. So don't hesitate to type in hashtag Celerdata. Awesome. It's Let's not make our guest wait and bring her up here. Hey Rachel, welcome to the Rabbit Show.
Hi, thanks for having me.
It's such a pleasure to have you. And like I mentioned, I was super excited about the topic, and that's why usually we do the sessions like the Rabbit shows on Thursdays. But this is kind of super interesting, so can't wait to learn more about data lake analytics, about StarRocks, about real time analytics, and much more from you. But for our audience to start with, can you introduce yourself, please?
Sure, my name is Rachel Beddor. I'm a solution architect at Celerdata. So that means I help our customers to implement our technology, which is based on StarRocks, an open source query engine and
Right.
database. So I help them to implement that within their existing stack.
Okay, that's awesome. And I'm pretty sure we would love to learn more about the open source StarRocks as well in the later in the session. So I'll definitely be asking you more about that. But to jump in, obviously, about our topic for today, I wanted to know what's driving the growth of data lake popularity, and what's it like to have single place to store all your data.
hmm Yeah, so with companies I work with, almost all of them are using a
Mhm.
data lake in some way. So if we think of a data lake, if you think of like Amazon S3 or Azure Blob Storage, things like that. There's also like Delta Lake based on Databricks that kind of is all a data lake. It's really popular now because people are able to store both
Mhm.
structured and unstructured data together. It's kind of like a single place where you can just put all your data. Not everyone is using it in their analytics stack, right? But almost every company is using a data lake in some way to store data. So I'm seeing a lot of that. It's cheaper, it's really cost effective, and scales really well. So you can just store any data in there and just throw it in there. And yeah, so it's mostly for data storage.
Okay.
But yeah, the query side is kind of where we come in. So a data lake itself doesn't allow you to query that data, right? To ask questions, to get insights from that data. That's not part of the data lake. You actually have to add something on top of that to be able to get insights from that data.
Okay, pretty interesting. And also, we have a comment here from Ryan who says also the storage is cheap.
Yeah. Right. Yeah. So it's super cost effective, right? And then it's low
Yep.
maintenance. Like in a traditional data warehouse, which is kind of the traditional way of doing things, you have process data that's structured. And that can be a lot of work to be able to like maintain that. So not
Mhm.
only is the storage cheap when you use a data lake, but it's also like less work for you. It's low maintenance.
Okay, pretty interesting. And do you have some interesting use cases that you've seen and that you could share with our audience today?
Yeah, I mean, so we'll see. So again, like you'll see when I'm working with a customer or when I'm looking at a different architecture or different architectures, like you'll see the data lake used in multiple different places within the business, right? But one use
Right.
case like I can think of right away is, that a data lake is beneficial is like, for example, if you're a company, you start a new product and it's like an IoT device, or you're testing a new product, it's an IoT device, and it streams data in a JSON format. Like that would be something that might be a lot of work if you wanted to put that directly into a data warehouse. So as an intermediary,
Right.
while you're doing the development, or maybe you do want to end up just keeping a copy of the data, you might have that right to a data lake. And that's super easy to do, even if the data is like in a JSON or it's, in an unusual format that doesn't traditionally work really well with the traditional data warehouse. So that's kind of an example of where you might, that scalability where you can just add a new
Yeah.
feature, and then also you can have a bunch of different types of data just live in the data lake, even if it's not all structured.
Okay. Yeah, that's pretty insightful for sure. And those are great use cases, because I feel that that's kind of coming out because you kind of closely work with those clients, so you know how it kind of all works together. Also, when we talk about data lake analytics, what do you feel like people should be aware of it? People should be aware of when we are talking about data lake analytics.
Yeah, so one thing is because it's not structured, right? You might need
Exactly.
a way to a lot of people will run they call it like a catalog manager. There's a bunch of different options. I think
Mm.
if you've heard of like Iceberg, that has some functionality there. Like people will use like Hive, Hootie. So these are all different like tools that you can use to kind of add structure to your data lake. So you could define a database and you could define tables. Later, I'm going to show a demo, and I've used Glue, which is AWS's ETL tool, and it also offers a catalog manager. And I use that to define databases and tables so that I can have that structure, so people, my colleagues or people at your company would be able to know where that data is and what it does, even if it's stored in a data lake.
Okay, pretty cool.
So
Do
yeah.
you, yeah, do you actually want to, since we are on this question, do you want to give like a quick sneak peek into it, how it works, so we can
Sure.
bring that up for our audience as well, so they can easily connect it.
Sure.
What do you think?
Yeah, I can show
Uh,
you guys a couple slides I made for like talking about StarRocks, and then we can get into the demo. We'll go
sure,
through the slides fast, and if you guys have questions, like feel free to just ask and interrupt me. We'll just keep this casual.
let's do
Um,
it. Yeah.
yeah, so StarRocks is right. StarRocks is the query engine or the database. It's not necessarily the data lake, right? The data lake lives underneath StarRocks. It's where your data could be stored. And you can bring data in a couple different ways. So you could bring data in through actually ingesting it into StarRocks as like into disk, right? You're copying it over. You could also use StarRocks to query data that's already in a data lake. And then that data wouldn't be copied over. And then we also have this box here, real-time data synchronization or ingestion. That's kind of like if you want to stream data into StarRocks, that's actually one of our key use cases. So you can stream data through like Kafka, or you can do a real-time synchronization. So that's like if you had a MySQL database and you do we call it CDC, change data capture. And so
Hmm.
every time something's changed in the MySQL database, it's automatically changed to StarRocks. You have a complete copy in real-time sync. Synchronization. So StarRocks is the query engine. It makes the query run really fast. And you would connect that into a BI tool. If like, you wanted to use Tableau or Power BI, you could actually run that in the back end. So your Power BI would connect to StarRocks and it would automatically send queries. You could also just like send a
Hmm.
SQL query, or a lot of people will connect it to their application. So they might have a front end web app, and you can connect it into the front end. And that way, say you have customers that need to do analytics on your product. That way your customers will get access to StarRocks. They might not even know it, right? It's coming through a UI. It has like charts or graphs about
Right.
whatever your product is. But in the back end, that's querying StarRocks to get that information.
Interesting.
So just further on those use cases, this is just kind of because I know it's hard to talk about
Hmm.
abstractly, so we kind of make these diagrams. So I'll just go through them.
Yeah.
Again, if you guys have questions, just post and we'll take them. But so the first one, like batch, if you guys are familiar with the term batch, that means just like bringing a bunch of data in at once, right? And that's the traditional way that OLAP or analytics databases worked. And we still support that. So actually, traditionally you would bring it in all overnight. You don't need to do that with StarRocks. You can bring it in as much as you want, but you can actually broker or batch it in from S3 or HDFS. So this is a really common way to just bring data into disk in StarRocks. You're actually copying it over from that data source, which is S3 or HDFS, and you're bringing it into StarRocks in a batch. But we can also do this, and I'll be, yep, do you have a question? Sorry.
No, go ahead.
Okay.
Yeah.
So make sure. So the second way is what I'm also going to show in the demo, and this is if we actually query on the data lake. So the data isn't brought into StarRocks. Maybe you need your data for whatever reason to stay in your data lake. You're not supposed to copy it over to a different system, or you don't want to. And maybe you want some query performance improvement upon like what you're already getting if you have like a pretty basic query engine on top, but you don't need necessarily the super fast that you would get with a disk. So this is the option you have to do an external table. So we call it like lakehouse analytics. So you can have that data actually live in a data lake and be queried by StarRocks. We can still offer like optimizations to make it faster. So we can do like a materialized view, and most people will use a kind of a combination of both internal and external. So you're not bound to one system. If you use StarRocks, you can use a bunch of different ones. The last one is the real-time analytics. So this is, again, if you're streaming data in. So another problem with a data lake, or a challenge with a data lake, is, right, if you wanted to stream data, you want to get data really fresh. It might be kind of hard if you wanted that to come. So say you have an IoT device or something. You're streaming data in from this weather sensor, whatever, and it's coming into the cloud. If you want to persist that to a data lake and then like read that data from the query engine, that would be added latency, right? Because now you have to put it in the data lake. That's going to have IO time. And then you're going to take it out of the data lake to be analyzed. That's added IO time. So what a lot of people will do is they'll stream their data directly into StarRocks, as well as maybe keeping a copy on the data lake. But this would allow you to, StarRocks can actually be a Kafka sync, so it can connect directly into Kafka, which is a popular streaming tool, and take that data and it can read it. That's how we're able to do that really fresh data. So when we say real time, we don't just mean like fast query speeds. We also mean freshness. That's really where, like when we talk about real time, we're talking about freshness. You're able to get that data that's from 5 seconds ago, so you're no longer stuck in reports that are recent only until yesterday. They're recent until 5 seconds ago, which is really our bread and butter and what we're able to do really well.
Okay, pretty cool. One question from my end, and this could be a very naive question that I wanted to ask, was around, how does it differ from other data storage and analysis solutions? Like, how do you look at it? Like, and this is the most basic question, but we have a lot of questions that I would want to take from our audience. But what do you think about this?
Yeah, so I think so. So when your data's on a data lake and you're finding a way to query it, there's a lot of different options, right? It's not just StarRocks. There's tons of different ways that you can query data. It really depends on your use case, right? So for StarRocks, we do big data. We were designed for big data, for high concurrency. So you're going to really see that performance improvement if you have like a lot of data, right? If you have a small amount of data, you might not need something like StarRocks to do the query engine. And then the other thing we do, and I think I have this on a slide, but I'll just talk through it, is so some other query engines, they will require you to do this process called denormalization. Fancy word, but basically what it means is, so typically we have, if you think of structured data, you have like a star schema, right? Like a fact table and dimension tables or lookup tables, and they're all connected through keys. In some other data system or query systems, they require you to stitch all that together. So you have to actually make this big, they call it a flat table. You have to make this big table where you actually have all those tables stitched together. This process is called denormalization. And what happens when you have really big data is that that's a really expensive, difficult process, because that's a lot of data to process. Like you might have to use a tool like Spark or something like where you have to actually maintain and pay for that tool just to stitch that data together. StarRocks doesn't require that. So that's a key differentiator. You're able to actually query your data as it comes in, like as a table. And so just a recommendation for if people are getting started with data analytics or data lake analytics, or just like their analytics and stack in general, when you're working with a vendor or when you're looking at different software to use for a query engine,
Mm-hmm.
ask if you have to do that denormalization process and try to find a way and see if that makes sense for you, right? Because if you have a small amount of data, that might not be a big deal. But if you have a lot of data, you need to add that into your total cost because you're going to have to do that processing in advance. So we don't
Yep.
require that. So that's why we are able to save a lot of cost in your entire architecture because you don't have to do that.
Okay. Yeah, pretty interesting. And I like what you mentioned about, obviously if you have the large data, you could, help. And at the same time, also about the fresh data. We also have a comment here from Tammy who says, love how it's fresh data.
Yeah,
So
fresh.
very cool. Yeah.
Nice. Yeah, I'll just speed through these quick because I don't want to give you guys too much slides because I know we're all slideshowed out. But so this is just again based on what you were kind of saying, just like the differences. So again, the no
Yep.
denormalized table. So that's a big deal. It means you don't need to do the joins in advance. You're able to add joins at the edge. So just at the point of query, it does the joins. And then concurrency. So we're built for concurrency. So we're built for big data, high concurrency. We scale really well. We have a simple architecture. And
Right.
that's kind of, why we're able to be so successful right now.
Cool.
And then this is a quick benchmark. You guys can look this up, but it's just showing the like competing software and that we're a little bit faster. And then on the right side, this is Trino. This is actually typically used for external tables, so data that's stored in a data lake and not brought into the actual engine. So we did our test both native, so meaning we brought it into disk, and we also did it external against Trino, and we were faster in both of those. So just the difference quickly between those two.
Okay.
And this is the how. So how we're able to achieve these things. So this is kind of the nerdy part. So we can really get into this because I know this is probably what your audience is interested in.
Yeah.
So I like to bring people to second and third points. So the vectorization is really like how StarRocks is able to do this. So when we say fully vectorize, like what does that mean? Well, it means like we vectorize, and by that we mean more like vectorization is like you do more instructions per CPU cycle. So every CPU cycle has a bunch of instructions executed at once. And a lot of software will say that they're vectorized, but we actually vectorize throughout our entire stack. So our cache is vectorized. Our hardware storage engine is vectorized. Everything in StarRocks is designed for vectorization. So my number one like thing I hear from my customers when I'm helping them do the implementation is they tell me they're like, wow, we were able to get way more out of every CPU cycle with StarRocks than we were before because we're just able to do all that at once. And that's what's enabling all these things. Like that's why we don't need the denormalization is because we're able to do more at once with every CPU cycle.
Got it.
Some other things on here, we do offer optimizations on top. Honestly, because of that vectorization, we're really fast out of the box. But we do have a cost-based optimizer that runs in the background, so your queries are always getting faster. We offer materialized views. This could be useful if you did have an external table and you wanted some of it to be faster. You could put in a materialized view on disk. We can do indexes too. So we have a bunch of optimization strategies that you can do on top of what we do out of the box. But honestly, we're pretty fast out of the box, which is really nice when you're just getting started. Not a lot of tuning required just to get started with StarRocks. It's mostly like cherry on top. And then the last thing I like to draw people's attention to is like the MySQL protocol. So you query StarRocks through MySQL like protocol, like it's all standard like SQL. There's nothing tricky about it. So anything that can query MySQL can query StarRocks.
Okay.
So yeah, any questions on here or anything you wanted to talk more about on here?
Yeah, there are a lot of questions coming in. So let's go and take those questions from our audience. Starting on with Sanjeev. So Sanjeev has a question. What is your opinion on data governance aspects on data lake? Any thoughts there, Rachel?
Okay, so I'm not a data governance expert, so I'm just going to put that out there. But I will say, so I that's like a common challenge that comes up, right? Because this data lake is just this all-encompassing place where you put any data, right? So I think that's part of why people will build the stack on top of the data lake, like a catalog manager that kind of says what's in there, and then you can probably work with a different layer that does a governance. If you were to
Right.
use StarRocks, right, you could use that also to do kind of like a governance. So you wouldn't allow people to just access raw data. They have to query through StarRocks, and then you have role-based access control in there where only certain people can issue certain queries, right? In the data lake side, I mean, I know like I use AWS S3 a lot, and they have like security so that you can make some data public or some data only certain people can access. But typically, I think the governance itself is done in a separate layer. Could be wrong, but I think that's typically how it's done. So it's done separately. So it's like on top of the data lake, you do a governance layer.
Okay. Those are pretty interesting insights. Let's take another question here from Ryan. So Ryan is asking, can you query across these options, OLAP engine and streaming in the same query?
Yeah, you can do that. Actually, it's like kind of the benefit. So we can do any data source, like you bring it into StarRocks. You can even do an external, like you can query over a data lake, and then you can also query internal data and streaming data all in the same. And you can do a join too, right? You can actually
Hmm.
join those together. So yeah, once it's in StarRocks, like once it's connected to StarRocks in some way, whether that's through connected to the data lake or bringing it into disk, you can query it.
Okay, very interesting. Another quick one here from Matthias, and this is from YouTube. Very interesting. Hello, what's the difference between data lake and lake houses?
So I think a lake house is kind of what like we were like showing. So I think my understanding is that like a lake house is kind of a blended way of doing that, where you do both. It's not just the storage, but also
Mhm.
like the query ability. So when we say we did lake house analytics, that's because we're able to do the analytics on top of the data lake. My understanding of lake house is that it's like a combination of both. I don't. Again, like I'm not the syntax expert, so I'm not sure what the exact word means, but that's kind of my understanding of the difference.
Yeah,
Like data lake is like storage, and lake house is kind of like this all-in-one engine.
yeah, awesome. All right, one quick question here from John. So John is asking, where does data quality come into this? If data scientists currently spend much of their time cleaning data, how and when does StarRocks handle this?
Yeah, so this is a challenge with data lakes too, right? It's like you just don't know what data,
Hmm.
like you just don't have that management. So you need that
Exactly.
catalog manager or some way of managing the data. So
Yeah.
StarRocks can work in this a couple different ways. So typically in a big data stack, they might have a like ETL layer before they get to StarRocks. Not
Hmm.
to do that stitching together necessarily, like, but actually to do the data cleansing. So you can do that in an ETL tool before it gets to StarRocks. So you would have the data
Right.
in the data lake, you might put it through an ETL tool to do cleansing, like deduplication, that kind of thing, and then put it into StarRocks. Another thing, you could do it on StarRocks too, depending on what your need was. So, for example, if you guys are familiar with the term primary key, it kind of means that like you only have one unique key for every entry, right? So if we just like pretend it's a table with a primary key and it says my birthday or whatever, it would say Rachel Beddor, my birthday. If you wanted to update that, it would only update one row, right? Like it's not
Hmm.
going to change. So we offer that ability, right? So you could do that. So you could have
Yep.
data coming in, and then it would just automatically update only one row in StarRocks. So hypothetically, like if that was your use case, that's kind of the cleaning. But in a like enterprise big data architecture, a lot of times if there was a tremendous amount of cleaning, you would do that in an ETL tool before it gets to StarRocks.
Okay. Awesome. That was great explanation, Rachel, and good question, John. One quick uh, your question from Sanjeev is how StarRocks is different from Redshift, BigQuery, or Snowflake. Any thoughts there?
Okay, so again, I don't like directly work with Redshift or BigQuery. I have worked with Snowflake quite a bit, so I can talk a little bit about that.
Yeah.
So Snowflake is like we call it like I think it's technically serverless. I don't know like what the exact terms mean, but basically when we talk about Snowflake, like it's like this online tool and you sign up and they pay for the infrastructure and then you put your data in there and then they charge you. Right. So right now we offer something similar to that, but it's a little different. So our cloud product for Celerdata, It's actually where you would host the infrastructure. So that's one difference. And if you want to use StarRocks, it's open source, so you have to host the infrastructure. So that's a big difference, right? This is a different buying decision or different architecture decision when you're thinking about how to build it. Snowflake also so one of the benefits of that is that it does scale up, but it can get costly, especially as you get bigger data volumes. So that's a big reason why that's a challenge with using Snowflake. Whereas if you hosted your own infrastructure, use StarRocks, you get more out of every CPU cycle. It's a little easier to manage that cost as we scale linearly.
Right.
But yeah, so I guess Redshift and BigQuery I'm not as familiar with, but kind of similar where they're doing the same thing like querying. StarRocks does offer some advantages. I think it's just it's a newer technology, right? So what some of the differences I've heard, I was working with somebody who's moving off of Redshift, and even just adding a node in StarRocks or increasing the size of your data, we automatically rebalance across a cluster. So in the back end, we have all this data and it's stored and it's distributed. We automatically rebalance, and that's not something you'd get with those other tools necessarily. I'm not sure about BigQuery or Snowflake, but that's just something to keep in mind. So it really depends on your use case, the amount of data you have. I think a lot of times these tools are really useful if you're getting started, maybe you have a small amount of data. But where I really work with customers or with people is when their companies are growing or their data is growing, their product's growing, and they start to run into constraints with some of the software that's designed more for smaller data volumes.
Okay, pretty cool. And that helped Sanjeev. So he says thank you and good explanation. Rachel, quick one. Actually, we have a few basic questions as well. Very generic questions. So can we help our audience here? Let me quickly pick one of the questions from Shakti. So Shakti is asking where we can get a large amount of data from companies to do analytics, for example, financial analytics. And she's a beginner, that's why she's asking that. So any thoughts there?
Yeah, that's really hard. So actually, that's an interesting challenge because I know what you're talking about. Because I'm going to give a demo later, and I give a lot of demos, and this comes up in my job a lot because I'm like, I want good data. Okay, so there's a couple of ways. So I'm going to show today a demo on benchmark data. It's called Star Schema Benchmark. So you can look at, there's Star Schema Benchmark, and there's TPCH. And they're similar. They're not totally financial data, but they're very similar. They're a retail use case data. There might be one for finance too. So go Google big data benchmarks, and you'll see some information. The downside of using that, though, just this is a hot take too. This is not Celerdata. This is Rachel Beddor speaking. But the downside of using that is that that's fake data, right? So that data's already been cleaned for you. And what happens in real life is that a lot of times, it doesn't look that great when it's coming in. And when you're first doing the implementation, your first troubleshooting, you might have things like a weird null character or, a column mismatch, weird things come up, right? So that's the downside of doing that, is that doesn't expose you to those kind of things that happen on a day-to-day basis as a data engineer. So there's some other ones you can use too. I've used there's one, it's called Movie Lens. If you look there's this website called Kaggle, it's on there. It's a cool thing they're doing now is they'll take a real data set, Movie Lens is a real data set from the early 2000s before there was privacy laws, and they'll do AI, it's propagation, and they'll use AI to increase the size of the data set, which is pretty cool. I haven't really played around with that, but highly recommend you try it out because I think that's a cool way to use real data but propagate it so you have big volumes of data, but it's real. So I think that's a cool blended option you should check out.
Okay, pretty cool. Actually, do you want to also give the demo to our audience right now? Because this will also help Shakti to have a look at what you're talking, how, and it might just help her in many more ways. So
sure, yeah. If you want to go to the other screen, I can show that.
Yeah, sure.
Okay, so just quickly, this is our architecture. Simple, FE, BE. FE stands for front end. BE stands for back end. FE, just a catalog manager. It's a small node. Honestly, 3 is all you really need, even for a big data workload. Just takes the query, parses it, sends it to BE. The BE is where all the processing happens, and that's where data is distributed across. So as you have more data or as you have more queries, you just add a BE node. Something to pay attention to here is that we have this storage engine and this execution engine. So if you were just using a data lake analytics and you weren't ingesting into disk, you wouldn't need the storage engine. That's optional. That's if you wanted to bring data into disk. And then this is not, I'm not a graphic designer and I made this morning, so this is not a great diagram, but this is just to show you the demo. So I'm going to be doing a demo. I'm going to show you what it's like to internally demo. So demo something that's data that's stored on disk with the StarRocks storage engine. And then data that's external. So data, I put this Glue catalog. It's basically Hive. It's AWS ETL tool. And then I have this data that's stored in S3. And so I'm going to show you first what it's like to query with this internal, the storage engine. And then I'm going to show you what it's like to query with this external. You're going to be able to feel the difference. And none of this has been optimized, just so you know. So like this is not necessarily super fast this time, but especially for the external, but we would optimize in real life for that. And I have 3 nodes. This is a pretty small cluster size, but this is kind of just a demo data set. And we have 300 million rows. And then like that person was just asking, this is SSB. So this is a benchmark data set. It's fake data. It's honestly a little boring, but we like to use the big volumes in demos. So I'm going to switch to that. So StarRocks is like the query engine. It's open source, but Celerdata has software that goes on top of StarRocks to help you just kind of like, we offer a lot of different features, but one of the nicest things is this UI and like cloud manager. So this doesn't come with StarRocks. This is Celerdata, but I use this for demos because it's just easier. So this is the environment I'm using, and this is just kind of the cloud management view. But I'm going to switch over to the editor. So this is kind of the data engineering view where you would get that query editor. I'm going to refresh my page actually to get the UI to realign. Oh, I got an error. So wasn't supposed to get that, but that's okay. So this is the internal. I'm going to start with internal. So this data is in, I'm going to select SSB. All right, we're going to refresh one more time. I think my colleague is using the cluster right now. So we share everything at Celerdata. You know, we're a share first company. So I think that's why there was a little delay. But I think we're good. So I'm going to use SSB. This is the default internal catalog. And here is my different tables. So you can see there, it's kind of large, and these are all stored on disk. So I'm going to run this. This is just telling it to record the query so I can show you later. So that's just some housekeeping. But the next line I'm going to run is to use the default catalog. So use the internal table. And then I'm going to run 2 queries. And I put these queries together just to showcase a little bit. So this is a count. So this is an aggregation. This is going to count all the rows in the fact table. I just want to show you guys how many rows there are. And then the second one is this aggregation over 4 join conditions. So again, remember that denormalization, we don't require that. That means we can do the joins at that point of query. So I'm going to do this so that you guys can see what it's like to join all this data right at the point of query in Celerdata. So I'll run these. Did I run this? Yeah. So the first one, okay, so you can see how fast that ran. So query 2 is the count. And this is 300 million. And it's a little hard to read. And that ran in 70 milliseconds. I did prepare for this. I was running these this morning. So just so you guys know, this is a hot run. A cold run means like, it would be like 1 second. So that's just because we're caching. We're using the caching engine. So this one is 232 milliseconds, but you can see when I ran it this morning, it was only 2 seconds. So it's still really, really fast to do those joins, even cold. Yeah. So this was internal. Now I'm going to show you external. And this is, I can actually just show you, this is what AWS Glue looks like. It's nothing, you know, it's kind of a lot. It's kind of a lot to look at if this is your first time looking at it. But basically, this is just a catalog manager, so you can see. Or actually, this is S3. Let me pull up my Glue catalog. So you can see in Glue this catalog manager, databases, and then I have tables, and they have an S3 location. In S3, so where the data is stored, it's kind of messy. I didn't do a great job of organizing this, right? But that's what a data lake is. You just throw data in there. Yeah. So I have all this line order data, and I just threw it in there. So it's a little messy. So StarRocks actually has to read through that to do these because it's staying there. It's not going into StarRocks. So StarRocks has this IO, and you'll see that is like we have to actually use this catalog manager and like find this data at the point where it is, and then bring it into memory and like do this computation. So this is actually quite a challenging thing to do. So I'm going to tell it to use the external S3 Hive glue catalog table. And then I'm running the count, and you'll see it's a little slower, right? And the reason it's a little slower is it's doing all that I/O. It has 100 different files. It's got to look at that catalog manager and ask the catalog manager, like, where is this data? Find the data, read through all the files. So you'll see that ran in 12 seconds. And now I'm running the query 3. This aggregates over 4 joins. And this one is also running in about, let's see, it's almost done. It's going to run in a couple seconds. So yeah, so 15 seconds for this one. So it did take a little longer, right? And I can actually show you why that is. So if I go into query history, this is another benefit of Celerdata. This isn't in open source StarRocks, but we get to show you kind of like how the query executed. So I'm going to pull this one up and just show you the query profile. This is a lot to look at again, but I just want to show you. Okay, so you'll see here, you can see why it took a long time. So this is connector scan. So this is actually connecting into the catalog. You can see it had 26% of the time was with I/O and 73% of the time was with processing. That's because we're not storing the data, we're just bringing the memory chunk by chunk and doing the execution. So that's why it took, it had both I/O latency and processing. And it was 2 seconds, 600 milliseconds to do that I/O. And actually, so I kept I got to open it up, but I kept a copy of the cold run. So this was the cold run for internal earlier today. So this is internal. And if you look at the internal part, so you can see that I/O time was only 1.4 seconds from disk. So it was like half the amount of time it took to do that I/O. So you're seeing that latency that's added that way. And then you're also seeing, what the difference in when it's disk versus external is. It's largely with I/O, but then also there's a little bit of processing overhead as well because it has to be brought into memory. But I just kind of want to show you guys the difference there. I know that was a little slow for that external one. Just so you know, if you were to actually use this in real life, we would optimize on top of that. But you can also see, right, like when you're using that internal disk, like that StarRocks native, you're getting really fast performance out of the box. Whereas if you did want to connect an external data lake, you might do a materialized view or something on top to make it a little faster. But we are able to do those joins even in big data, even on an external. And that's actually pretty unusual. Okay. I know I went through that fast. Do you have any questions about the demo?
Yeah, please bring on any questions that you have around the demo, and Rachel is here to answer all of those. But Rachel, we definitely have a few comments here. One from Sanjeev coming here. Well, this is amazing. First time I saw an open source on top of that glue catalog. That means it will easily be compatible with Hive Metastore as well. What do you think?
Yeah, I guess they're kind of the same. I'm not an expert, but yeah, they're compatible. Yeah.
Okay, fantastic. And I did see another comment here. Yeah, this is very interesting. Rashid says, also one quick question that we saw here from YouTube. What are it's about the trends. So what are the emerging trends in real-time analytics, and how do you see them shaping in the future of the field?
Yeah, it's kind of an interesting, and I'll answer this as Rachel and not as Celerdata. But it's kind of an interesting thing because I think it's becoming more and more common to see freshness or real-time analytics come into play, like just throughout the industry, right? So this is definitely, like you said, like it's an emerging field. So some of that is brought by other like streaming, there's new technology in streaming as well. If you guys have heard of Kafka, and there's a company behind Kafka called Confluent. So they offer, and there's also like, I think one's like Red Panda. So there's a couple different options now, Pulsar for streaming. And so that's also like causing more proliferation because there's just a better technical stack now than there used to be. But yeah, I think it's definitely like an emerging trend. I will say it is so a lot of times actually we don't necessarily need data within millisecond freshness, right? Like a lot of times we can actually it's just minutes, or even that's an improvement on what we had in the past, right? Because in the past people are used to running reports overnight and they only have data that's fresh as of yesterday. So I'm seeing a lot of incremental, like companies will be like, they won't go 0 to 100, right? They won't go necessarily like, I want millisecond freshness now. So I'm seeing a lot of companies will start by being like, okay, we want 10-minute freshness, and then they move up and up and up. So it's nice that StarRocks can offer that like really fast, like almost instant freshness right off the bat without them needing to do that like incremental. But you could do a combination, right? You could stream data into StarRocks, and you could also do that batch. Like you could do a batch every 10 minutes, and that would maybe be a combination of ways to get data in. So yeah, I'm definitely seeing more and more of it, and it's definitely getting fresher and fresher. Like the requirements are increasing.
Okay, yeah, those are pretty interesting insights there, Rachel, and good question there, Money. And talking about this, when you were kind of showing me the demo, I was also thinking a lot around data lake, and that brings me to one question, which is, what can folks who are considering a data lake do if their use cases overlap with data lake limitations? Any
Mm-hmm.
thoughts that you have there, Rachel?
So what I recommend is if you're a company, you're like redesigning your data stack or you're like getting started with the data lake, is to always have like a
Yeah.
central architecture for your entire company. Because what happens
Mm-hmm.
is sometimes people have an architecture for each use case, and that can cause like if you guys have heard the term data silos, that's like the right hand doesn't know what the left is doing. That's the kind of idea behind a
Mm-hmm.
data silo. So what you want to
Right.
do is have a centralized architecture, and that's obviously a lot easier said than done. But that's my recommendation for getting started. Like, find out every limitation that you have on that data lake. Maybe it's with one business unit and then you have another use case. Find that out so that you can find a tool that works for all of them, or a system of
Mm-hmm.
tools that works intelligently with all of them, right? So you'll probably will need a catalog manager, right? But my advice is, find a catalog manager that works for you that you can use across your entire stack. So that is a lot of work because it means you have to go to every business unit at your company or think about every product at your company and try to think about how can I design this so that it can scale? How can I design this so that I can add new products in the future and that it works for every limitation I have now so I can prevent that siloing?
Okay. Awesome. This is very good information, and at the same time, we have a comment here from Brian. Centralized architecture. That's brilliant. So that's nice. Also, quickly wanted to take another question here from our audience. I know there are tons of questions coming in, but just trying to pick as much as I can in terms of the questions here. All right, let's take this one. So, how can businesses ensure that the data they are analyzing in real time is accurate and up to date? Very interesting.
Oh yeah, that's a good question. So the reason that's actually a big reason why you'd have to use like StarRocks, right? Because you
Exactly.
need a tool that's gonna manage that for you. So StarRocks is like once and only one. So when that data comes in from Kafka, it goes into StarRocks or it fails. It doesn't. You're not doing. There's a formal term for it. I always forget, but you're not like having a mismatch in accuracy. It either ingests or it doesn't. And so that's where a tool like StarRocks is used for, so that you can make sure that the data is up to date. And actually, when we ingest from streaming, we write it to disk like right away. So that's a difference between some other architectures. Some of them will go into memory, which might be okay for some use cases. But the problem is if you go into memory and that node goes down, you have a bit of a problem, right? Because you lost that data then because that was like volatile, or I think it's called volatile, right? And it goes down. But
Yeah.
for us, we write to disk, so even if that node goes down, you're able to recover it. So that's a big benefit of using like a tool like StarRocks. But yeah, you do need to think about that, and that's why you would need to use like a sophisticated, even an open source, but a sophisticated tool to make sure that you're getting accurate data.
Okay, yeah, these good question there. So definitely brings a lot of insights, Rachel. Also, quick question that I had was around, and this could be very easy question, but at the same time, sometimes it's kind of, people kind of get a lot confused in this part, which is around, actually, if you can explain what a data lake is and how it differs from a data warehouse.
Sure,
So
yeah.
that would help our audience. I know it could be very easy for you to put it out there because
Yeah,
you can
no,
talk in this place. Yeah.
I was actually thinking about this last night when I was thinking about this, and I was like, I don't know if like it's hard, right? Because you get used to these terms, and then
Exactly.
nobody asks you like, what is a data lake? But let me tell you, because I thought about this. So a
Wow.
data lake is like you store all your data there. You can put unstructured, you can put structured, you can just throw stuff in there, and it's kind of a way that you can just store a bunch of different data all in the same place. A
Mm,
warehouse, the way I understand it is traditionally that's like process data that has like a rigid schema that's ready to be analyzed, right? A data lake isn't ready to be analyzed. It's just kind of data that's stored there. It's more like storage. But a data warehouse is like data that's been processed, and that can be a lot of work to process that. It can be a little more expensive too. And then it's ready to be queried. So that's kind of the big difference. It's mostly the structure and then the cost, scalability. Data lakes just scale really, really well. You can just add more and more
yeah,
data. A data warehouse, depending on which one it is, you probably do need to think about that, like in a central, like we were talking about architecture. You have to think about that architecturally before you embark on that journey of scaling it. So it's just a data warehouse is a little more formal, and then
right.
data lake is more. It's a more like common now. It's almost everybody's using them now for just storing data.
Yeah, good explanation there. Definitely clarifies a lot of things. That also brings me, I'm just shifting gears a little bit here, but that brings me to a question which I guess someone already asked around data scientists, but still I would love to know about, about your thoughts, Rachel, about what role do data scientists and data engineers play in data lake analytics, and how do their responsibilities actually differ? Because there's a lot of talking, sometimes around data scientists versus data engineers, but how does it work in the data lake analytics space? So can you tell us a little about that?
Yeah, sure. So I'm a data engineer. So I have an engineering background. So I am not a data scientist. I'm trying to learn more about it because I think there's a lot of overlap. But just to kind of tell you a little bit. So I think for me and from my understanding, like a data engineer does that. Remember when we were talking about like, okay, design an architecture for your company, like figure out how to
Hmm.
give the analysts what they need. That is what a data engineer is primarily doing. They're designing this architecture. They're making sure they can deliver the result for the data scientists to be able to get insight from the data. So my understanding is a data scientist's job is to get insight from the data at the company or the organization to make decisions to like make business or decisions to move the company forward, right? And that can take like a lot of different. That might be, I don't know, like Power BI or Tableau or like a BI tool. I know a lot of data scientists love to use like Python and they love to use like AI and
Yeah.
Jupyter notebooks, right? I'm trying to learn more about that actually. But yeah, so there's kind of like a different role to play, but I think there's a lot of overlap, right? Like it's really important for the data engineer to understand what the data scientists are doing, what they need to know, how do I give it to them? And it's important for the data scientists to know like the limitations of the software they're using. One benefit of using actually like a StarRocks type tool is that since it's really automated in the background and you don't have to do a lot of tuning, that's kind of
Hmm.
nice, right? Because the data scientist doesn't need to know, oh, if I do a left join, it's going to be different than if I do, like it'll just do that in the background, which is a benefit.
Nice. Yeah.
Otherwise, if you're using software that's maybe a little more old school, the data scientists sometimes I'll be talking to data scientists and they'll actually kind of know. They'll be like, oh, you can't do a join on this specific use case because it'll
Hmm.
be slow. But if I do it, XYZ, it will work. So they'll sometimes know a little bit about the data engineering stack. I think the goal for the data engineer is for them not to have to know, right? Like you want them to be able to issue queries and then be answered and not have to
Yeah.
worry about how that happened or like what the limitations are for how that happened. So that's my understanding. I again not a data scientist, but I'm definitely interested. So I don't know if you do some live streams on data science, I'll join and maybe
Oh
learn a little
yeah,
bit
for
more.
sure. We have a lot
Yeah.
of data scientists all the time, and then data engineers like you as well. And everyone has their. We also have some enterprise leaders who kind of come in and talk at a neutral level, and shares across. But this has actually been the favorite question lately for all the guests coming in. Either I'm asking or either the audience is asking around data engineering, about data scientists, what their roles, how they kind of differ in the data warehousing space, data analytics, data lake analytics space. So, but I think that is pretty good explanation, Rachel. And coming from an engineering background, you definitely have a strong role around the data engineering space. But happy to share any of the sessions that we do. That also
Yeah.
brings me, yeah, that also brings me to another interesting question here from our audience. Let me quickly take this one because I think this yeah, this would be interesting. Can you share a success story of a company that has leveraged StarRocks to drive business growth? Any company that comes to your mind, and
Sure.
obviously,
Yeah.
yeah.
I'm thinking of a company. I'm not sure if it's I can't remember if I'm allowed to like say the name, so I just won't. But yeah, so like one
Don't say
example,
the name. Yeah.
so like one company we're working with, they really decreased the amount. So they have like this metric store type thing. So they have like a set amount of analytics. In the past, they were using, I think they were using Druid, or they were using one, or ClickHouse. I saw there was a comment about ClickHouse. They were using one of those where it requires a denormalization process,
Yeah.
where you have to add those tables in advance. And they were able to reduce that by like 75%. So they still had some denormalization going into StarRocks for like things they wanted really, really fast, right? They didn't want to do any join, they just
Got
wanted
it.
it in advance. But they were able to decrease the amount of their denormalization ETL pipeline by like 75%. And that helped them to save costs, that helped them to move forward
Wow.
and have a more flexible
Yeah.
platform. I'm seeing a lot of, for Celerdata, especially like at my job at Celerdata, I'm seeing a lot of, and again, speaking from me, but I'm seeing a lot of,
Yeah.
I think, especially with like with the economic climate, I'm seeing a lot of companies come to us because they're looking to save money. And that could be through the ETL pipeline, through reducing that. That could also be if they're
Yeah.
using a tool that maybe wasn't built for big data, right? And I won't name names, but like there are some that maybe aren't built for the size of the data that they're working with. And they're realizing they're spending a lot on infrastructure, or they're spending a lot on subscription prices, like licensing. So I'm seeing a lot of that because, again, we get more out of every CPU than the other software. So we're able to reduce the size of their infrastructure in the cloud. And that is a big reason right now with the economic climate that I'm seeing a lot of that come in.
Okay, that's amazing. Also, Rachel, quickly taking another one. We have Ashwin joining us. So Ashwin loves the energy in the
Yeah,
session.
good.
Ashwin, to be honest, I love Rachel's energy as well. And he also has a question here. Are you a layer of abstraction of ClickHouse?
Yeah, so that's a great question. So we're kind of I don't know, we're kind of a competitor to ClickHouse, I would say. So I could show you a million slides on why we're better, but I'll just try to summarize it. So um ClickHouse is a great product for especially if you, I think StarRocks is designed really for, big data. We're designed for scaling and for big data. I
Hmm.
think ClickHouse is a good product if that works for your architecture where it is right now. Um, the reason that a lot of people are switching off of ClickHouse and onto StarRocks is because the scaling is a primary one, and then the denormalization. So my understanding is that ClickHouse requires stitching the data together, and then you put it in. If your data is already like that,
Right.
that's great. No worries, right? And if your data is not going to grow, then no big deal. But what happens is that the data grows, and then they need to add a node. And in ClickHouse, it's kind of a manual process. Last I checked, I don't I'll have to refresh my memory, but last I did it, it was a kind of a manual process. You got to actually like tell it how to like shard. It's like called like sharding. You know, we don't want you to have to
Mhm.
deal with sharding. That's just a big word. Like, we want that to happen in the back end. So in StarRocks, that all happens. You add a node, it just automatically redistributes. It's way simpler. So way easier to scale up. And then we don't require that denormalization. So different strokes for different folks. That's what we say in the Midwest where I grew up. But I think it really depends on the needs of your business. And that's why, again, like with designing an architecture for your entire business is really important, so that you understand like where do you want to be, and is the architecture that you're choosing going to get you there? Because if it doesn't scale well, then you probably need to evaluate a different option.
Okay, pretty interesting. Thanks for that. Also, one quick question that I had for you, Rachel, was, but before we jump on to those questions, I would like to actually announce the first winner that we have. So this is the cool raffle that we were doing for Celerdata, and in this raffle, we are announcing about the one of those winner who will actually get a signed copy of Data Engineering Fundamentals book, and this is very cool way of doing the raffle. We have 33 entries. So Rachel, this is how we draw, and those who have typed in hashtag Celerdata are entered into the raffle, and one winner will be automatically choose through this raffle. Let's see who it is. It's Tammy. Tammy,
Ooh,
congratulations.
congratulations.
So this is the cool way of putting it out the winner. Tammy, feel free to reach out to me, and you get a free book, a signed copy of Data Engineering Fundamentals by Joe. So pretty interesting. All right, Rachel. Actually, I know for a fact we're keeping in mind the time. I know we've discussed about a lot of things about data lake analytics, real-time analytics, StarRocks, data. I think you've given us amazing insights about data engineering versus data engineers versus data scientists and their roles and how it kind of fits in the data lake game altogether. So this was pretty insightful. But if folks want to reach out to you to learn more about data lake analytics, about real-time analytics, which is the best place they can reach out to you? Yeah.
Yeah, so you can, like, email me, rachel.bedor@celerdata.com. We also have, like, a Slack channel for StarRocks. So if you go to StarRocks
Nice.
dot I think it's, like, StarRocks.io, just find the website, like, do a search, and, if you click on the Slack icon, you can join our community Slack, and so that's a really great way to just get started with StarRocks with the open source. If you were interested in an enterprise product, of course, email me directly or fill out the interest form on Celerdata, and somebody will contact you. But again, StarRocks is a great way to get started and learn more about the community. So definitely check out the Slack channel. That's my recommendation.
All right. I've what I've done is I've shared the link, and also Tyler has put out the link. So feel free to reach out these places, and Rachel will be there to help you and give you more explanation about many more cool things that they do at StarRocks, Celerdata. But this was truly super insightful, Rachel. It was such a pleasure to have you here
Thanks
on the
for
Raffle
having me.
show. Yeah, and definitely we'll plan a 2.0 session where when things kind of develop more, we'll have something more like data lake analytics, more like data warehouse, and much more. So can't wait.
Can't wait. Thank you. Thanks so much. Thanks to everybody who joined.
Awesome. Thank you everyone for joining us today and bringing some amazing questions for Rachel here. We'll definitely catch up again with a new guest next week. Thank you again. Take care. Have a nice day.